Okay, let a particle moves in a circular path. Let the radius of this be 2 meters. So I'll give initial angular velocity initial tangential velocity 2 meter 3 meter per second, and let it have constant angular acceleration 2 meter per second square. At t equals 0, this is a velocity. Okay, what I given angular acceleration and initial tangential velocity. The particle moves in circular path with constant angular acceleration alpha equal to 2 radians per second square with initial linear velocity 3 meters per second. At t equal to 4 seconds, find first one A tangential, second one total acceleration, third one beta, fourth one number of revolutions. What is given? The information is linear velocity and angular accelerations are given. A tangential, A normal, total acceleration, beta, then number of revolutions. Okay, we have to find out all these quantities. Strictly, it is moving in a circular path of radius, how much? 2 meters. Again, we know alpha. So we know alpha. What is the direction of alpha? Let me just specify that one. This is alpha. Actually, alpha will be out of the plane. For our convenience, we are showing it like this here, alpha. So first, what is A tangential? We know A tangential should be equal to R alpha. So what is the value of R? 2 into 2. So this is 4 meters per second square. Then what is the like a velocity of the particle at 4 seconds? So velocity of particle, tangential velocity should be equal to how much? So first we'll calculate omega. Omega equal to omega naught plus alpha. We don't know omega, but how the things are related? V naught is equal to R omega. So here I'll write V naught by R alpha into T. Substituting this value, V naught is 3, this is 2, alpha is 2. After what time? At 4 seconds. So this will be 1.5, 9.5 radians per second. Then I'll get tangential velocity, R omega. Value of R, 2, 9.5 will be 29 meter per second. Then what is A normal? You can also use omega square R, any of the formula. So 29 whole square by...
Sir, it is 19, sir, not 29.
19, sir.
19. This will be A normal. So after getting this A normal, then total acceleration we can determine. So what is the formula for this? A normal square plus A tangential square. Do we know A normal? S, we know A tangential. And then tan beta. What is the tan beta? AN by AT. So somewhere here, rough diagram, I'll show it. So this will be the, it can be anywhere, you can show it anywhere. So this should be the V tangential. This will be the A tangential. This will be the A normal. Okay, got this. And total acceleration vector will be somewhere here like this. Almost in all numericals, there's a generalized idea you'll be having. So tan beta is AN by AT. Substitute this value. Just have a right formula. No need to simplify. Okay, we got this one. AT, AN, A, B, all that one. So what type of motion it is? Non-uniform circular motion. So the particle initial will start here with a V naught and alpha or A tangential acceleration. So this is at t equal to 0. And we are just saying that at 4 seconds, it will be a rough estimation. We don't know where it will be. Just we are making guess at t equal to 4 seconds. Okay, now let's go for number of revolution. What to do for number of revolution? We should calculate theta first. So how to bring theta? Theta is equal to omega naught t plus alpha t square by 2. Let me substitute all the values. Omega naught initial angular velocity. So this should be v naught by r. Substituting all this, we'll get the theta. So v naught by r is how much? 1.5. 1.5 time is 4 will be 6. Alpha is 2. This is 2. Time is how much? 4 square. 16 plus, this will be 22 radians. Now how to get number of revolutions? I'll show everything in one page. It'll be easy for you. 22 by 2 pi. 11 by pi revolutions. Pi is how much? 3.14. So we'll get a rough estimation like now where actually the particle is. Means did it completed 2 rounds, 3 rounds? So that information will be available for us. 3.5 I'm getting. What do 3.55 it is? Now, what we should interpret? What we should interpret? This is number of revolutions. What I should interpret? So how many rounds it has completed? So it will start like this: t equal to 0 with initial velocity v naught. 1 round, 2 rounds, 3 rounds. I'm using word round so that it will be very easy for you to imagine. Technically, I should say 1 revolution, 2 revolution. So I'm just say 1 round. It go round once, 2, 3. Then what will happen? 3.5. Got this? So theta will give us 22 radian. When you look at 22 radian, it will not flash much, no? 3.5 revolutions. Yes, it will help us really a lot, like what actually going on. Got this? So like this, what happen? We do introduce some quantities for our, so that we can express things very easily. Or it should contain lot of information. Say, if they give alpha, nothing but angular acceleration. From that, what you can get? Tangential acceleration. Are you looking at this equation? If you know tangential acceleration, then you can also write some equation. Better stick on to equations of motion because they will help you a lot. I'm just taking help of the equations of motion, you see. Okay, now time taken for first revolution and time taken for second revolution. Anybody will answer? The best question is what I'm asking. What will happen to time taken to complete the revolutions? What is the time taken for the first revolution and second revolution? Any comparison? You know enough of kinematics. You should
The
answer
time
by.
taken in first revolution will be more than time taken in second
Yeah.
revolution.
What type of motion it is? Accelerated motion. in accelerated motion, what happened to distance covered in equal intervals of time keep on decreases, no? Similarly, here also time taken for the nth revolution and n minus revolution. For nth revolution, it will be less compared to n minus 1. Got this idea? So shall I say that time taken to cover the successive revolutions, shall I say, decreases? I have to add this. This is very important. Time taken successive revolutions decreases. This is what the theoretical questions are. You are going to get it. Okay, we'll take the next one. Just only instead of kinematic straight line, we are discussing kinematics in like in circular motion.